BM-13, Katyusha. Why the Germans never managed to solve its main secret. On July 14, 1941, at the Orsha railway station in Belarus, the usual frontline bustle prevailed. German echelons arrived one after another, unloading tanks, fuel tankers, and fresh motorized infantry units. The Wehrmacht soldiers felt like masters of the situation, as the offensive was going according to plan and the Red Army was retreating. None of them could even imagine that in a few minutes this station would turn into a real hell and the survivors would flinch at any howling sound in the sky for the rest of their lives. At 15:15, a completely unfamiliar sound tore through the air, something between a roar and a piercing screech. And then the entire station in an instant drowned in a fiery cloud of monstrous power. Tanks overturned and caught fire. Fuel tankers exploded one after another, scattering streams of burning gasoline around. German soldiers in a panic dashed between the burning wagons, not understanding what was happening and from where death had come. Those who were lucky enough to survive later said that the earth literally burned under their feet, and the metal melted from the unbearable heat. That same evening, the chief of the German General Staff, Franz Halder, made a disturbing entry in his diary that the Russians near Orsha had used some new, previously unknown weapon. A squall of flame-throwing shells completely destroyed the railway station, along with all the echelons, military equipment, and personnel of the arrived military units. German intelligence received an urgent order to find out what this weapon was and how it was designed. Thus began the hunt for the secret that German specialists would unsuccessfully try to solve until the very end of the war. And yet, only recently, less than a month ago, the fate of this weapon hung in the balance. On June 17, 1941, at the Sofrino testing ground near Moscow, a large review of new types of Red Army weapons took place. A representative delegation led by the People's Commissar of Defense, Marshal Semyon Timoshenko, and the Chief of the General Staff, Army General Georgy Zhukov, inspected tanks, guns, and other military equipment. The rocket launchers were left for last, and when the high-ranking military officials finally approached two strange machines with some kind of rails instead of a truck body, clear disappointment was read on their faces. Instead of formidable gun barrels, they saw an incomprehensible structure of metal guides on which lay long shells, looking like huge cigars with plumage on the tail. The members of the commission became bored, deciding that before them was another fantasy of designers that had no practical value. However, the skepticism instantly vanished when the command for a volley sounded. Two launchers fired 24 shells in a matter of seconds, and the target field literally heaved from the explosions. A wall of fire, fountains of earth, and the complete destruction of everything in the square at which the fire was conducted made an indelible impression on the commission. The decision was made lightning fast. Already 4 days later, on June 21st, literally a few hours before the German attack on the Soviet Union, the government signed a decree on the mass production of rocket launchers and ammunition for them. This coincidence seems almost mystical, as if Providence itself took care that the new weapon had time to appear at the very last moment before the terrible war. The official name of the installation was boring and technical. Combat Vehicle 13, abbreviated BM-13, based on the index of the rocket shell of 132 mm caliber. But very soon the soldiers would come up with a completely different name for it, affectionate and formidable at the same time. Production was launched immediately at two enterprises, the Voronezh Comintern plant and the Moscow compressor plant. Work proceeded at a frantic pace. Designers and assemblers worked 12 to 16 hours a day, without days off. On June 26th, only 4 days after the start of the war, the assembly of the first two production machines was completed in Voronezh. The launchers were mounted on the chassis of the ZIS-6 3-axle truck, which had good cross-country ability and payload capacity. Each machine carried 16 rockets on 8 guide beams located along the longitudinal axis of the vehicle. A volley of all 16 rockets took 7 to 10 seconds, after which the unit could quickly change position without waiting for a retaliatory strike from the enemy. On the night of July 1st to 2nd, 1941, the world's first combat unit of rocket artillery set off for the front. A special battery under the command of Captain Ivan Flyorov. Its composition included 198 people, 7 BM-13 combat vehicles, 44 trucks, 1 passenger car, and 7 special vehicles. For zeroing in, the battery was even given a 152mm howitzer. These people did not yet know that they were to enter history and forever change the understanding of what artillery could be. Flyorov's battery arrived at the Western Front in the midst of the heaviest defensive battles. German troops were rapidly advancing deep into Soviet territory, and the command urgently needed any means capable of slowing this offensive at least a little. However, the new weapon was so secret that even their own generals did not really understand how to apply it correctly. The BM-13 crews received the strictest order: under no circumstances allow the capture of the installations by the enemy. 30 kilograms of explosives were placed on each machine, and the soldiers took a special oath to destroy the equipment in case of a threat of encirclement. Secrecy reached the point of absurdity. For a lost board from a rocket shell packing box, one could end up in a penal battalion. The NKVD guarded the new weapon with all possible strictness, and each member of the crew understood what responsibility lay on his shoulders. The regiment commander was personally responsible for the safety of each machine, and the loss of even one installation threatened him with a military tribunal. Therefore, when 19-year-old soldier Dmitry Zherebko, together with the driver, managed to save a damaged machine and return it to the unit, the commander hugged him and burst into tears right in front of the formation. He said then that the guy had saved not only the machine, but also all the commanders from inevitable reprisal. The first strike on the Orsha station on July 14th was only the beginning of the combat path of Flyorov's battery. On the same day, inspired by success, the artillerymen struck a second blow at a pontoon crossing across the Orshitsa River, where German troops had gathered, waiting for their turn to cross. The effect was no less destructive. The crossing was completely destroyed along with the equipment and enemy manpower located on it. The German command was at a loss, trying to understand what kind of weapon was unleashing such a squall of fire on them. The main feature of the BM-13 was the incredible speed of the volley. If an ordinary artillery battery required minutes to fire a comparable number of shells, the rocket launcher did it in a matter of seconds. A volley of one machine of 16 rockets took no more than 10 seconds, and a full volley of a battery of 7 installations unleashed 112 rockets on the enemy almost instantly. At the same time, each shell carried a combat charge weighing almost 5 kilograms, and fragments during the explosion heated up to 800 degrees and ignited everything around. Precisely because of this, a legend arose about a thermite charge in Katyusha ammunition, although in fact there was no thermite there. But even more terrible than physical destruction was the psychological impact on the enemy. The sound of flying rockets was unlike anything heard before. Some described it as a piercing howl, others as a screech or a roar. But everyone agreed on one thing. This sound instilled primal horror, even in the most hardened soldiers. In the affected area, literally everything flew into the air. The ground burned underfoot, and those who managed to survive after such a shelling remained in a deep state of shock for a long time, unable to adequately perceive reality. The Germans quickly came up with their own nicknames for the new Soviet weapon. Most often it was called Stalin's organ because of the external resemblance of the launch guides to organ pipes. Other names were also found: Black Death, Hellfire. But the Soviet soldiers christened their installations affectionately and in a homely way. According to one version, the name Katyusha was born right at the compressor plant, where the assemblers, mostly very young girls, themselves called their products that. According to another version, the reason was the letter K in the factory designation of the products of the Voronezh Comintern plant. But the most common legend connects the name with a popular pre-war song about a girl who went out to a high, steep bank. In the army environment, the song was quickly remade in a military way. We love our dear Katyusha. We all love how she sings. She winds the soul out of the enemy and gives courage to friends. And indeed, Soviet soldiers more willingly went on the attack after the enemy positions were covered by a volley of rocket mortars. The suddenness of appearance and the staggering power of the fire raids had a demoralizing effect on the enemy, which was difficult to overestimate. Already at the end of July, the 2nd and 3rd batteries of rocket artillery arrived at the Western Front under the command of Lieutenants Alexander Kun and Nikolai Denisenko. Both struck their first blows in the last days of the month, confirming the highest efficiency of the new weapon, and in August 1941, the command decided to form not separate batteries, but entire regiments of rocket artillery. Moreover, even before participating in battles, these regiments were assigned the honorary title of Guards Mortar Regiments of the Artillery of the Reserve of the Supreme High Command. No military unit in the history of the Red Army had been honored with such a title before, and this clearly showed what great importance the country's leadership attached to the new type of armament. On August 8th, the table of organization of a rocket launcher regiment was approved. Each regiment consisted of 3 battalions, and each battalion of 3 batteries with 4 combat vehicles in each. A total of 36 launchers and almost 1,400 personnel. A volley of one such BM-13 regiment consisted of 576 rockets and could cover an area of over 100 hectares, destroying everything living in its path. For the production of weapons for the first regiments in 1941, the factories manufactured 593 launchers, working around the clock in 3 shifts. German intelligence from the first days of the appearance of the new Soviet weapon received a categorical order: capture at least one installation at any cost. Despite all the precautions of the Soviet command and strict control by the NKVD already in the autumn of 1941, the Hitlerites managed to get a BM-13 in full combat gear. The trophies were immediately sent to Germany, where the best specialists set about studying the mysterious weapon of the Russians. The design of the launcher itself was not particularly complex, and German engineers quite quickly figured out the principle of its operation. The design of the rocket shell was also no revelation to them. However, one element put the German specialists in a complete dead end. Having disassembled the rocket chamber of the shell, the Germans found 7 powder sticks made of ballistite powder inside, 6 around the circumference and 1 in the center. Each stick had a diameter of 40 millimeters, a central channel of 8 millimeters, and a length of about 550 millimeters. It was these sticks that, when burning, created the reactive thrust that accelerated the projectile to huge speeds and provided a flight range of up to 8.5 kilometers. Ballistite powder itself was well known and widely used in large-caliber artillery, especially naval. But how the Russians managed to organize the mass production of such large and high-quality sticks remained a mystery. The thing is that the molding of powder elements from ballistite powder was traditionally performed on hydraulic presses. The technology had been worked out for decades. A roll of powder plasticized canvas was loaded into the press die. Then the piston slowly lowered at a temperature of about 90 degrees, and molding began. When the powder ran out, the piston was also slowly raised, and thorough preventive maintenance of internal surfaces was carried out. Observing extreme caution due to explosive residues, the process was periodic and extremely low output, but there was simply no other way in the world. According to the calculations of German engineers, to mold sticks of such a size as those used in Katyusha shells, a hydraulic press of enormous power was required. They knew that such a press existed only among the British and was unofficially called the Mammoth Press because of its gigantic size. The height of this unit reached 4 floors, and its operation was incredibly difficult and dangerous. German intelligence received an urgent task: to find high industrial buildings in the powder factories of the Soviet Union in which such presses could be located. Having discovered them, the Luftwaffe was to immediately strike and destroy production. German agents searched for these buildings for 2 years, but found nothing. The reason was simple. No giant presses existed in the Soviet Union. Soviet specialists went a completely different way, and this decision became one of the most brilliant technological breakthroughs of wartime. A group of scientists, under the leadership of the outstanding chemist Alexander Semyonovich Bakayev, took an ordinary macaroni screw press as a basis. Yes, exactly that same press on which macaroni products were produced in food factories in peacetime. Of course, a simple macaroni press was not suitable for working with gunpowder. Given the rigidity of the ballastite composition, the screw and the drive to it had to be radically reinforced. The press was equipped with a special heating jacket to maintain the desired temperature. A special bell-shaped forming tool was developed, also with heating. At the output from it, a powder billet of a given diameter with a central channel continuously came out, which only remained to be cut into sticks of the required length and cooled with water. As a result, a continuously operating installation was created, the productivity of which was 8 to 10 times higher than the capabilities of any hydraulic press. However, working with such an installation required iron discipline and the highest qualification. It could not be stopped for more than 10 minutes, since at a molding temperature of about 90 degrees, the thermal decomposition of the powder mass could begin. A short-term stop led to a defect, and a long downtime threatened an accident with an explosion. The installations were placed in ordinary one-story buildings with traditional protective earth embankments, and no high-rise structures were required for them. The strictest secrecy regime and harsh discipline did not allow German agents to discover the production sites of powder sticks for Katyushas. But in the autumn of 1941, a new, even more serious problem arose. Ballastite powder is a thermoplastic, and at the molding temperature its thermal decomposition begins, which must be categorically avoided. To prevent this process, a special chemical stability stabilizer, a petroleum processing product under the trade name Centralit, was introduced into the composition. There was no own production of Centralit in the Soviet Union. It was purchased in Romania. With the beginning of the war, when Romania came out on the side of Germany, deliveries stopped. The existing stocks did not last long, and the sea transport carrying Centralit from England was sunk by German submarines. Production of powder sticks began to rapidly decline, and the activity of using BM-13 at the front began to fade. The Germans decided that the Katyushas had come to an end. However, they were cruelly mistaken. Bakayev's group, working in conditions of the severest time pressure under the constant control of the NKVD, was given an urgent task to find a replacement for the imported stabilizer. The search was conducted in emergency mode, around the clock, without weekends or holidays, and a solution was found in the shortest possible time. A cheap and available domestic substitute for Centralit made it possible to completely restore production. For this achievement, Alexander Bakayev and his associates were awarded the Stalin Prize, and during the war years, 6 new powder factories were built using the new technology, providing the front with ammunition for rocket artillery. While Soviet chemists solved the problem with gunpowder, designers continuously worked on improving the launchers themselves. In April 1943, the unified model BM-13N was adopted into service, in which all the shortcomings of the first samples were taken into account. Engineers critically analyzed every detail and every node, striving to increase the manufacturability of production and reduce cost. But the main change was the new chassis on which the rocket mortars were now installed. The first Katyushas were mounted on the Soviet ZIS-6 three-axle truck, created on the basis of the two-axle ZIS-5. This 4-ton vehicle with a 6x4 wheel formula possessed good cross-country ability, however its production was limited, and the characteristics did not fully meet the requirements of wartime. Moreover, at the beginning of the war, the production of ZIS-6 had to be curtailed due to the evacuation of factories. A new platform was required, reliable, powerful, and available in large quantities. And such a platform appeared thanks to Allied supplies under the Lend-Lease program. The American Studebaker US-6 truck became a real gift for Soviet rocket artillery. It was the world's first mass-produced truck with 3 driving axles, providing excellent cross-country ability in any conditions. All-wheel drive allowed the machine to move confidently along the sodden frontline roads where domestic trucks were hopelessly stuck. The American freely crossed small river fords, not fearing to damage vital components located sufficiently high above the ground. At the American recommended payload capacity of 2.5 tons, Soviet drivers quickly found out that the machine was capable of carrying much more and mercilessly exploited it to full capacity. Given the privileged position of the Guard's mortar units, the command decided to supply them with the best available equipment. In total, about 200,000 Studebakers were delivered to the Soviet Union under Lend-Lease, and a significant part of them became carriers of rocket launchers. That is why in most military photographs, Katyusha is captured on the characteristic silhouette of an American truck with angular fenders and a steeply inclined windshield. However, this in no way means that without the Studebaker, there would be no Katyusha. The chassis could be anything, and this did not affect the killing power of the installation itself in any way. Just the American platform turned out to be better and more modern, emphasizing the special status of these troops. In addition to the famous BM-13, the Soviet industry produced other modifications of multiple launch rocket systems. The younger brother of Katyusha was the BM-8 installation, which used 82mm caliber shells grown from RS-82 aircraft rockets. Due to their smaller dimensions and weight, these units could be mounted on a wide variety of platforms. They were placed on T-40 and T-60 light tanks, on railway platforms, armored boats and torpedo boats, even on ordinary draisines. On the Caucasian front, where tracked and wheeled vehicles were difficult to maneuver in the mountains, the BM-8 was modified for firing directly from the ground without a self-propelled chassis. The main modification for M8 shells was the launcher on the chassis of the American Ford Marmon truck. These machines carried 24 guide beams on which 48 rockets were installed. From 1942 to the end of 1944, 2,086 of them were produced. Before the appearance of foreign chassis, similar installations were placed on a 3-axle modification of the famous GAZ 8AA 1.5-ton truck, which honestly pulled its weight on all fronts of the Great Patriotic War. The older and most formidable brother of Katyusha was the Guard's mortar BM-3112, which received the respectful nickname Andreyusha in the troops. The story of this weapon began in 1942, when designers managed to create a fundamentally new M30 rocket. It was a standard rocket engine from the M13, but with a completely different combat part of 300mm caliber. This head part was huge and massive. It contained almost 29 kilograms of explosives compared to 5 kilograms in a regular Katyusha. Because of the disproportionately large head, the projectile resembled a tadpole, which apparently gave rise to its masculine name. However, the strange shape of the projectile seriously worsened the aerodynamics, and the firing range fell by more than half compared to the Katyusha. The Andreyusha volley reached only at a distance of 2,800 to 4,000 meters versus 8.5 kilometers for the BM-13. But on the other hand, the destructive power of each shell was simply monstrous. In 1943, an improved modification, the M-31, appeared with an elongated, streamlined head of an oval shape. Aerodynamics improved slightly, the range increased to 4.5 kilometers, and the mass of explosives remained the same, about 30 kilograms. For this ammunition, by April 1944, the BM-31-12 launcher was designed on the chassis of the same reliable Studebaker. A total of 1,807 were produced. The German rocket mortar Nebelwerfer, which received the nicknames Jackass and Katyusha from Soviet soldiers for the characteristic sound during firing, had comparable efficiency, but was significantly inferior to the Katyusha in mobility and range. The achievements of the Americans and the British in the field of rocket artillery were even more modest. The American T-27 installation with 16 guides repeated the original Katyusha scheme with a transverse arrangement, which Soviet engineers had long ago abandoned due to strong rocking during a volley. The Allies never managed to catch up with or surpass Soviet rocket artillery, either in efficiency or in scale of production. By the middle of the war, Soviet rocket artillery had turned into a formidable force capable of solving the most complex combat tasks. On September 8, 1941, a decree of the State Defense Committee was issued, which actually turned the Guards mortar units into a special privileged branch of troops. They were completely removed from the composition of ordinary artillery and formed a separate structure with its own command, subordinate directly to the Supreme High Command headquarters. The first commander of the Guards mortar units was military engineer of the first rank Vasily Oborenkov, one of those whose name appeared in the author's certificate for the rocket auto installation as early as February 1940. Even a separate People's Commissariat of Mortar Armament was created, the only one in the Soviet Union that dealt with only one type of weapon. It existed until February 17, 1946, providing the front with everything necessary for conducting rocket warfare. About 30 types of rocket projectiles of various power and purpose were mass-produced, from light 82mm to heavy 300mm monsters. Designers continuously improved the ammunition, enhancing its accuracy and range. A modification M-13 UK with increased accuracy appeared, then the long-range M-13D, capable of hitting targets at a distance of up to 12 kilometers. Production of rocket weapons did not stop for a single day, even in the most difficult conditions. In besieged Leningrad, where people died of hunger and cold, factories continued to produce rockets for Katyushas. The assemblers at the enterprises were mostly very young girls. Some had barely turned 16. They worked on a par with adults, understanding what significance their work had for the front. When the finished machines lined up in the yard of the factory before being sent to the front line, the girls went out to the crews and said, "Beat the fascists, finish them off, and we will provide you with Katyushas." From July 1941 to December 1944, the Soviet industry produced 6,844 BM-13 launchers. This was the most massive rocket system in the world, and no other army had anything like it. By May 1945, the Red Army was equipped with combat vehicles of three main types: BM-8, BM-13, and BM-31-12. Each of them occupied its niche and solved specific tasks, and together they constituted the most powerful striking fist capable of crushing any defense. Rocket mortars participated in all the major operations of the second half of the war. At Stalingrad, their massive volleys helped grind down Paulus's surrounded grouping. On the Kursk Bulge, Katyushas met German tank wedges with a wall of fire, mowing down infantry and destroying armored vehicles. During the crossing of the Dnieper, rocket artillery suppressed enemy fortifications on the opposite bank, clearing the way for landing groups. In the Belarusian operation Bagration, Guards mortar regiments smashed retreating enemy columns, turning roads into a graveyard of burned equipment. Heavy M-31 shells, with their monstrous destructive power, turned out to be irreplaceable in urban battles. 30 kilograms of explosives in each rocket reduced fortified buildings turned by the enemy into strongholds to rubble. Where ordinary artillery spent hours destroying one house, an Katyusha volley solved the task in seconds. During the liberation of Warsaw, Budapest, Vienna, rocket mortars worked practically without interruption, supporting assault groups and suppressing pockets of resistance. In the final stage of the war, during the Berlin operation, the Soviet command concentrated a previously unseen power of rocket artillery. 1,510 combat vehicles and 1,795 launch station frames were ready to unleash a stream of fire on the enemy. When on April 16, 1945, the offensive on the Silo Heights began, the sky over the German positions lit up with thousands of fiery tails. A volley of hundreds of Katyushas merged into one long roar that made ears pop for many kilometers. Tons of steel and explosives fell on the heads of the defenders, plowing through trenches and turning fortifications into a lunar landscape. In Berlin itself, rocket mortars fired practically point-blank, knocking garrisons out of blocks turned into fortresses. Heavy shells pierced through walls and exploded inside buildings, leaving the defenders not a single chance. The roar from the explosions did not cease day or night until the red banner rose over the Reichstag. A weapon born literally on the eve of the war went through the entire long path with the Red Army, from the terrible defeats of 1941 to the full triumph in the enemy's lair. Katyusha proved its right to exist in thousands of battles, becoming the prototype for all modern multiple-launch rocket systems, from Grads and Uragans to Smerchs and Tornadoes. If you liked this story about the legendary weapon of victory, be sure to leave a like and write in the comments what other military equipment you would like to hear about. Subscribe to the channel so as not to miss new episodes, and be sure to click on the bell. Then you will definitely see notifications about the next video. Ahead are many more interesting stories about the machines and weapons that forged our victory.